Hi, my name is Eric Foley, and this is my Lab 7 about black holes. Our objective was to determine the mass of the black hole using data about how the position of a star revolving around that black hole, and we know the mass of that star. So, finding the mass of the black hole, we have the equation F gravity equals g m1 m2 over r squared, with g being the gravitational constant of 6.7 times 10 to the negative 11th, and m1 being the mass of the black hole, m2 being the mass of the star, and r being the distance between the two. So then we solve for m1, as you can see here, and then in my code it's the same thing. BLCK is set as the mass of the black hole, and m1 is the mass of the black hole in this equation. So other principles we used to get there. So F net equals dp dt, F parallel equals d times the magnitude of p over dt. F net equals F perpendicular plus F parallel, and the same as dp is true for dp dt, in that dp dt parallel plus dp dt perpendicular equals dp dt. And you can see that in my code here. So dp dt equals the change in momentum over the change in time. Set that equal to F net. And then for dp dt parallel, we found the magnitude of p final minus the magnitude of p initial. So this is the change in momentum over dt, which is what we found from this equation above. And then we multiplied it by p hat to find dp dt parallel instead of just the magnitude. And then farther down, we found dp dt perpendicular using the sum of dp dt parallel and dp dt perpendicular. So we got dp dt overall minus dp dt parallel. So that is equal to dp dt perpendicular. So this is all my code, and when I ran it, it output the mass of the star, and that was my conclusion about the mass of the star. So what does it mean? This is a picture of my module running. The red arrow is F perpendicular, the blue arrow is F parallel, and the black arrow is F net. F is the force that causes the change over time. So the only force acting on the star is the gravitational force in the black hole. So that's why the black arrow, which is F net, is always pointing towards the center of its path. And the blue arrow, so F parallel, or dp dt parallel, F parallel, sorry, is going in the same direction that the planet is moving. And F perpendicular is pointing towards an angle 90 degrees from the parallel. So the relationship between F and dp dt is that F net points in the same direction as dp dt net, F parallel points in the same direction as dp dt parallel, and F perpendicular points in the same direction as dp dt perpendicular. Because F is the force that causes the change of momentum over time, so that means they'll be pointing in the same direction. But what you're actually observing as you watch the planet move around the black hole is dp dt, because you're watching the velocity change and you're watching the direction change, but you can't actually observe the force. The what if question: if the black hole was a different mass, I decided you couldn't find this mass because with this distance the star is from the black hole, the force of gravity would be greater if the mass was greater, or less if the mass was less. So this means that either the velocity of the planet would have to be greater if the force of gravity was greater, or r would have to be greater, meaning that the star would have to be farther away from the black hole. So for the path to be the same, either the velocity or r has to change if the mass has to change, so I said this wasn't possible.